This is the last video for 6.6, solving exponential and logarithmic equations. This is video number 3. This time we're going to apply it to some real life problems here. So number 9 says, your sister is cooking her famous chili. When she takes it off the stove, its temperature is 212 degrees Fahrenheit. The room temperature is 75 degrees Fahrenheit, and the cooling rate of the chili is R equals 0.051. How long will it take to cool the chili to a serving temperature of 95 degrees Fahrenheit? So we're going to use this thing we call the Newton's law of cooling. So it gives us an equation, and it says T with a subscript of 0, so T naught is what we call that, is the initial temperature. T with the base of R, so TR, is the surrounding temperature, so that's the room, and R is the cooling rate. And then the T, the capital T, is the temperature after the lowercase t minutes. All right, so that gave us some information. So I'm going to take this equation that we're going to use, and that's what I'm going to be plugging things into. So I'm going to rewrite it here. All right, and then I'm going to list all of these variables, okay? We have a capital T without a subscript. We have a T with a subscript 0. Remember, that's our initial. We have a T with a subscript of capital R. E is not a variable. Remember, that's a number. Up in the power, I have a lowercase r and a lowercase t. Okay, so there's lots of variables. Whenever I have equations with many variables, I like to write them out, so I can pick through the word problem of what I have, okay? So let's start off with what we have. So let's read this again. She's cooking her famous chili. When she takes it off the stove, its temperature is 212 degrees. So that's the temperature it is starting at, and that initial temperature is T naught. T, the subscript 0. So this is 212. Okay. Then it tells us the room temperature is 75 degrees Fahrenheit. Okay. That's the temperature of the room, the surrounding temperature. So that's our TR here. So TR is 75. Okay. Then it says in the cooling rate, it even tells you is R. So I know my lowercase r, which is right here, and that is 0.051. Okay? And then it tells you, let's see, how long will it take the chili to be at a serving temperature of 95 degrees. So that is the temperature we want after some amount of time. So that's my capital T. So that's 95 degrees. Oh, we don't even need to write the degrees. Okay, so what I'm looking for here is my time. That's my question mark. Okay, so let's fill in what we have. So capital T is 95. It equals parentheses T naught, which I said was 212, minus TR, which we said was 75, end the parentheses, times the number E to the negative power, and it's R times T. So it's 0.051, and we don't know T, so I'm leaving it in my equation. Okay, and we're solving for T up here. So again, anytime I have something, oh wait, whoop, we're not even done. I didn't write all of this problem out. Silly me. I missed something, and I see it right here. This plus. We had a plus TR right here on the end. You might have seen that already. Okay? Well, we said TR was 75, so it has this 75 here on the end. Whew, I almost missed that. It gets confusing when we have commas in there. Okay, so we need to get this T out of the power, okay? But we can't do that until what's taken to that power, which is just the E, is all by itself. So I've got to move these things out here. So I'm going to move the 75. We add or subtract first. That's always what you do before you multiply or divide. Okay. So I end up with a 20 over here. And I'm going to go ahead and do this math right here. Okay, so 212 minus 75 is 137. E to the negative 0.051 t. Okay, again, E is still not all by itself. It is being multiplied by 137. So I need to divide by that 137. I'm getting mighty colorful here. Okay, so I have this canceling out, so I have 20 over 137, and I am just leaving it that way. It's more exact as I work. 0.051t. So now e to the power that has a variable in it is all by itself on one side. So now I need to write this as a log to get that power out of, or I'm sorry, get that variable out of the power. So remember, if my base is e, that means I have a log base e. Well, that's the same thing as saying natural log. Okay, log base e, and then we jump over on the equal sign of 20 over 137 equals the power, which is negative 0.051 t. And then to get t by itself, we now just need to divide by the negative 0.051. So over here, I'm left with t equals, and we're going to have to get out the calculator to figure that out. So on the top, I have the natural log of 20 divided by 137. I'm going to go ahead and push enter, then divide that answer by a negative 0.051. And I get 37. So this says, let's make sure we answer the question right. How long will it take? I'm just going to round it. It's going to take about approximately 38 minutes. Okay. I made this look a little more complicated than it is, but it's taking what you were given, just I would list this, and then you're going to plug them into the Newton's law of cooling, okay, which is all of this. All right, and then just solving. All right, let's try it with our last problem. If I can find it, here it is. Okay, now this one's not a Newton's law of cooling. This one is a compound interest formula, okay, or a problem. It says you deposit $300 in a CD account and it pays 4.5% interest. How long, rounded to the nearest hundredths, will it take to double your money if it compounds quarterly and continuously? These are two different equations. We've covered this equation, okay, and that equation is A equals the principal times 1 plus the rate over n to the n times t power. Continuously is going to use that number e. It's A equals P times e to the RT power. Okay? So if I list the things I have in this problem, let's just do A first. I have a capital A, a capital P, a lowercase r, lowercase n, and a lowercase t. If I list the variables I have in this equation, I have a capital A, a capital P, an r, and a t. This e is not a variable. Just don't forget that. Okay. All right. So back to the quarterly problem. Let's see what we have. First off, you deposit $300. That is our principal. That's the principal in both of these equations. So I know this is 300. Okay? And it pays 0.45% interest. Now we have to write interest as a decimal. So you have to move the decimal place over 2 spots. Okay, and that's our rate. So 0.045, okay, that's this, and both of them. 0.045. Okay, the thing we don't know here, I'm sorry, what we're trying to figure out is how long. So we know our question mark is our time. So we need to figure out these other letters here. Now, it does say, how long will it take to double our money? Well, if our money started with $300, doubling it would be $600. So I'm trying to get to $600. I want to know how long that takes. And the only other variable that I have left is this n in my compounding quarterly problem. Now remember, n is how many times it compounds in a year. And this tells me quarterly. Well, there are 4 quarters in a year. So those n's are 4. Okay, so we're going to start it off just by doing A. I've already plugged in everything I know for both of these problems because a lot of it was the same. And I'm going to solve. Okay, so in A, I know my big letter A here is 600 equals the big letter P, which is 300, times 1 plus my rate, 0.045, over n, which is 4, to the power of n times time, t. Okay, and I don't know t, so it's my only variable that I have left. All right, let's go about solving this. Okay, I'm going to divide by, because I need to get what's to the power of t by itself. Okay, so I need to get rid of that 300 first. So I'm going to divide by 300, and I get 2 equals. Now I am going to go ahead and simplify in here, and this will be to the 4t power. If I simplify that, let's see, I get 1.01125. Okay, I'm not going to round since that is the exact number you get. 1 plus 0.045 divided by 4. Okay, if I don't round, my answer stays exact. So I can write all those numbers down. I'm going to do it. All right, but now I need to get this variable out of my power. So I have to write this as a log. So when I do that, it's this base. So I have log base 1.01125. Jump over the equal sign, so it's of 2, equals the power, which is 4t. And to get that power by itself, or I'm sorry, get that variable by itself, I need to divide by 4. So I get that t is going to be approximately, and I'll probably end up rounding this, but let's see here. So I'm going to get this log. Now if you don't have, here I'm going to do this without changing. Remember, if you have the log base, go ahead and change it and type in that exact log there. But if you don't, do the change of base formula where you use just the common log of 2 divided by the common log of 1.01125. So I push enter, that's the top, that's my numerator, and I divide that by 4. And I get about, 15.5, and we're talking, what are we, our units here are years, okay? All right. So now let's try to compound it continuously. Okay, so we have to use the same information, but we're going to use a different formula. So if I plug it in, I have A equals P times e to the power of r times t. Again, my variable's in the power here, but I have to get that by itself before I can get it out of the power. So I've got to divide by 300. 2 equals e to the 0.045t. Now I have what has the variable in the power all by itself, so I'm going to write this as a log. Now, log base e is the same thing as saying natural log. Jump over the equal sign. It's going to equal the power, 0.045t. To solve for t, I divide by 0.045. Okay, so I'm left with t all by itself there, so t is going to be, we all have the natural log button here, so natural log of 2, enter, divided by 0.045, I get about 15.4 years. So you can see the more it compounds, the sooner you'll get to that bigger number. All right, so give this a try by going to your practice and doing problems 19 and 20. Use the Newton's law of cooling, and the number 43 uses your compounding equations. And then submit on Big Ideas and submit your score into Canvas.